So, hold my beer and watch this. This was a challenge put to me by an old friend who said you should submit titles, or submit talks entitled this. And I said, well, what should they talk to me about? And he said, I don't care, just always submit talks like that. So I had one at London for a workshop, but I wasn't able to attend, so Fosden gets to hear this, and then maybe someone else. So unfortunately, too, I also was, I was writing slides right up until like 2 minutes ago, so I didn't get a beer. So I don't have a beer for anybody to hold. So if anybody wants to pass one up. So, let's see. So, who am I? My name is Stevan Little, but I also respond to Stevan, because that's how it's spelled, and all the Russians at work pronounce it that way, so whatever, just call me Stevan. In 2005, I wrote Moose. In 2010, I started a project called the P5 Mob, which was an attempt to put Moose into the Pro Core. I've spoken about it previously at FOSDEM and at other workshops and Perl, things like that. It's been a long time running, and there's been multiple different versions, but now I'm done. So that's what this talk will actually be about. We'll talk about the different pieces that I built for this, and then I'm putting them out to the community to test them, play with them, experiment with them, see where it goes, and hopefully then in 2020 I will profit from this. We'll see. Assuming the world is still around. So, anyway, so P5 Mob for the Ages, it had a bunch of different iterations. The first one was obviously called P5 Mob. It ended up being an overcomplicated mess. There was a P5 Mini Mob, which was an attempt to do a small version of it that we could bootstrap the first version with, so we could write the mop inside the mop, and then within it just got really, really messy and complicated. Didn't work. I took a year off and sort of like let my brain refry. P5 Mob for Redux was yet another attempt. That one ended in just a giant mess of excess code, which led me to write P5 Mob Excess, which pretty much just segfaulted really reliably and did not need development. I'm not a C programmer. And so finally, this was the last version of it. Again, seriously, what the fuck? And that one actually proved fruitful. It took a little while. I had to refine it, and I've been playing with it for about a year and a half. But it's essentially what I've done in the last maybe month or so is I've taken all the pieces and I've split them up. And part of the reason I split them up was I wanted to be able to I actually wanted to be able to use some of these parts and not have all of them. So some of these parts require 522. Some of these parts require 514. Some of these parts require 510. Some of these parts actually are backwards compatible to 5.6. So at work, we mostly use modern Perls. I work for Booking.com. We're mostly on 5.18.2, and we're about to upgrade to 5.24. So I don't really worry about these things. But in my personal work, I do a lot of stuff that I want to support across many versions. So what I'm about to present to you is 6 different CPAN modules that when you put them all together, you can get yourself a very nice, modern-looking Perl object system that uses all the new bells and whistles. You'll see that at the very end, but we're going to start first with something that actually is backwards compatible to 5.6. So I call this universal object. It is on CPAN right now, and what this essentially is aims to be is your core base class. So if you have Java, you have C#, you have things like this, you get an object already that's a built-in constructor and it understands certain things. This was one of the things that Moose provided that people really liked was it's basically its own constructor. So you could just say use Moose and then immediately you got a new and you could make instances of your object and it was very easy out of the box. So this module basically does that. And what it does is it provides a certain set of conventions about how to build your objects. So the first convention is that you put all your slot information, meaning all the information about the fields that you want to have inside your class, you put that inside a package variable called uppercase hats. This is very similar to how you would do inheritance, which would be with the @isa. Okay? So it's building on those same types of conventions, and essentially you put in there a key for the slot name, and then a subref, which will provide the initial version of that slot. From there, it also gives you other things. It gives you new, build args, blast create, refer slots, and build demolish, which I'll explain as we go here. So has, as I said, was the slots. So here's an example of that. So we want to inherit from a universal object, and then we define 2 slots, x, and if the default value is a 0, y, and the default value is a 0, so a very simple point class, and that's it. We have a constructor now because we inherited it from a universal object, and all other fun stuff comes along with that. So this is really just a convention. There's no code that actually implements this. There's just code that uses this and understands this convention. This convention also works great for inheritance. because of the way Perl does list flattening and stuff like that, this point has is basically brings in all those fields and inherits them in there. And we can actually tell the difference between an inherited field and a non-inherited field because this sub, if we actually dig under the covers a little bit, we know which package it was actually compiled in. So we know that this was a slot for package 3D, and the other inherited ones are for point, and we always can know that because we can always track that information. So new is your, it's very similar to Moose constructor. You can take a hash graph, or you can take key value pairs, also very similar to how Perl 6 does things. So we have that in place. Build args is also something that comes out of Moose, which also we stole from Perl 6, which is a way to essentially mangle the arguments on the way in. So key value arguments are really simple, really straightforward, very easy to use and everything like that, but they're not always the API you want. Sometimes you want a different API. So sometimes you want to just pass in maybe two integers, and you want it to basically inflate into the key value pairs. So this is what you would do with build args. If you've done any build, if you've ever used a build arg feature in Moose or anything like that, you should be really familiar. Basically, I notice that I only have two elements in my arrays, and I say, okay, I'm going to assume that's my two element form, and I'm going to turn it into this and return it, or I'm just going to call this super. And all build args does is it mangles the arguments, turns them into canonical representation of a hash graph, which is key value pairs. The next step is bless and create, which is very tied to repr and slots, so I want to explain this. This is really where all the extension mechanisms are situated within this work. So you pass your args into new calls bless. Bless is actually going to get that canonical hash graph that build args just created, so bless gets that first. Bless's responsibility is, can we guess? To bless, yes. That's really literally all it does because it just calls create to construct your instance. So most of your extension points, if you wanted to do different kinds, if you want to do array-based instances or scale rep instances, or how you inherit from non-universal object classes, all that ends up being done in create. So create can construct your instance however you want. It calls repr, which the default version just gives you back an empty hash graph. So that's the representation. This is all very Perl 6-ish. Is that still in there? It's still part of Perl 6? Repr?
Yeah, repr.
Okay. So just want to make sure. Returns a hash graph, and then it also calls slots, which gets that has information. So say you wanted to do all this, but you don't like the fact that I'm storing the slot information it has. Override slots, put it wherever you want. I don't care, because as long as that gets it, all the other construction protocol bits, they all fit together. So as I said, overriding a class that itself doesn't use universal objects, so has its own different set of constructors, is as simple as this. So if you think most times with constructor, you call the super constructor, and then you do things to it yourself and make sure it's blessed into your class. This will actually end up resulting being blessed into our class properly, but we're calling the legacy constructor, we're passing anything into it, so setting up their arguments as they expect, and the result of that will then go through all of our other steps. So we'll get blessed properly into our class, all the slots that we expect will go into it, things like that. It's also how you get custom instances. So return the representation as an array wrapper. Well, so this will essentially put all that together. So it gets the slots from the class, it gets the representation, and then it basically pulls the things out of the protos, which is the arguments, and if it doesn't have them, it just calls the slot initializer right there. And it puts the whole thing together, and we always know that X is at 0 and Y is at 1, and it's very easy. Of course, this doesn't inherit well, so you have to do this, but this is kind of weird. Map sort keys slots, and this gets really kind of cryptic and messy. But this is how it would work to inherit stuff. You can also do scalar references. You can do whatever you want in here. If you wanted to do a custom C type instance, you could do this. So all these extension points are good. That was a little heavy.
Why bother sorting that?
Yeah.
What's that? Well, because you want it consistent. Otherwise, keys are just going to give you random things, and you want to know the position of your
Oh,
things.
because self is an array.
Yeah. So it's an array. Messy.
Yeah.
I didn't even bother showing how multiple inheritance would not work and all this stuff. So anyway, they get a little fancy, but it allows you to pretty much have a lot of freedom with your expression or with your representation types and things like that. And then there's build and demolish, which was part of Moose. Basically, new calls build all, and build all will look all the way through your inheritance chain, call every build that it sees in it in the proper order, And then on the opposite side, destroy, we'll call demolish all, which will then demolish in the exact opposite order that build happened, so that you can properly, basically get rid of, or set up and get rid of resources in your class. So, and all this, 5.6. Who here uses 5.6 still? Awesome. Nobody. If you did, now this works with this. It uses MRO, which is a 5.10 feature, and MRO compat if you need something before that. But otherwise, it has 0 dependencies, and it is basically ready to go into core as soon as we feel it's stable enough, and Sawyer says okay, or I buy him enough, he can cook one or the other. Anyway, so that's universal object. Universal object I specifically pulled out because I wanted to use that in a lot of places. I wanted to just be able to write a very small CPN module with minimal overhead and be able to have a nice base class, a nice construction protocol, because I ended up re-implementing this over and over and over. So that's there. It's out of. The next phase is something that I've fiddled with a number of times, and this is a bit of a weird one, but I think this is really useful. So Perl has within it a set of compiler phases. Okay, we all know what these are. Anybody a little confused in these? Anybody just seen them but never knew quite what the hell they were good for? Okay, all right, good. So everybody knows. Okay, so begin happens immediately. You have a begin block. As soon as it's parsed, it's executed. It doesn't know if there's more begin blocks in front of it. It doesn't care if there's any begin blocks before it. It just immediately runs. Check will run last in, first out order. Init blocks will run first in, first out order. Unit check is one of my favorites. Unit check. So begin, check, and init will all work with the compile phase of the interpreter. Unit check, however, every time a compilation unit is created, so every time you use a module, or every time you load a bit of code, or eval a bit of code, unit check gets fired at the end of that compilation stage. So that becomes very, very useful in terms of finalizing things or cleaning up resources at the end of the compilation phase before you hit runtime. And then, of course, there's the end block. So these you can just write, begin and then put a block there, or check and put a block there and stuff like that. That's all well and good. However, you can't easily programmatically install a new unit check block or a new begin block or a new thing like this. If you had that ability, you could do all sorts of things for what's called multi-phase programming. It's basically macros on crack. Is how I would say it. If you think of macros have an expansion time. So they expand and then the code gets compiled. Well, these can essentially work in a similar sense in that they can expand the code. Now, it's not just text expansion like C. It's a little bit closer to maybe Lisp, but not even that because there's no real syntax. It's Perl. You can just manipulate the shit out of everything because the interpreter leaves everything open, and so you can do all that. So what is this useful for? Well, not a whole hell of a lot. It's a low-level internal thing, but you can do interesting stuff. So what I've done is I've created a module that allows you programmatically either in queue, meaning just run this in the next iteration, or you can specifically append or prepend to the list. Because actually what Perl does internally for all these blocks, it just has an AB, a Perl array, and it just stores them in there. So you can push onto it, you can pop on it, you can unshift, you can do whatever you want. I don't recommend doing whatever you want because it probably will set fault for sure, because you're going to confuse Perl very quickly. But what this tries to do is give you sensible versions of it. So for the most part, the most useful part that I found of it is when you're in a begin block, you can actually in queue for something to run in the next begin block, which just becomes really useful for weird mob stuff, which I'll show you later. But this right now will give you some idea of maybe where you might be able to use this. So in your import, if you were to do a bunch of things in your begin routine, I mean, nobody does that, right? We don't have $1 million euro companies built on that. We do that way for booking. Liz. Guilty. She's guilty. So at booking we do a lot of preload stuff, and we try and preload as much as we can in the compile time of the Perl interpreter, so that all our worker lifetimes are very nice and very clean. This would be a way maybe to check it. So we would check, we'd start the timer, and then actually at the end of compilation, for sure, we could then check the timer. So if we were to do a lot of stuff, we would test things like that. It's hard to really come up with examples for this module because it's so weird. But it's one of those things that when you find yourself, when the solution presents itself, and it's this, there's no other way to do it. So it's really about controlling the different compilation steps. And the reason why is because a And this ends up with two main benefits. One, for the pre-fork. So you're not pre-forking and then doing a bunch of work. You're able to do all the work in the pre-fork and then handle the copy on write and things like that. And then also modules like B::C, which compiles your Perl application to C, which cPanel uses, should theoretically be able to also benefit from this. Because the way they work is they get to the check phase and they freeze. And then that's where your C program starts up from. So all that work should be done beforehand. Anyway, this is silly little stuff. Okay. Next module is also a little funky. Begin lift. Okay. How many of you fucked around with Haskell at all? Okay. So Haskell has this idea of being able to lift subroutines and being able to run them at earlier points and stuff like that. This is basically a ripped off, half-assed Perl version of that. What begin lift does is it allows you to create basically things that look pretty much like a statement keyword. And they operate very much like a statement keyword. And they also do all their work within the compile phase, and then they leave literally no trace of themselves afterwards. So it becomes a no-op when it's actually run and executed in runtime. So this one, it's very easy to show a simple example, but there's a lot of stuff under the covers. I'm not going to get into it because I'm running low on time. I want to get to the next stuff. But it's just simple. So if you wanted to write a Moose-style clone, we call it Caribou, you could do begin lift. Begin lift, and we install into the caller, so the calling person, we install extends. And then whenever extends runs, it does this. So this is obviously pushing onto the ISA. So it's just basically mimicking some sort of inheritance relationship. And then you can do this in your code, and it is functionally equivalent to, in a begin block, doing the ISA there. So again, all of the work is done in the earliest time possible, and there is nothing left for the interpreter to do at runtime. So this was also one of the things with Moose, is that Moose did a lot of stuff at runtime, and so it had a lot of overhead in that sense. This cuts out a lot of this overhead because it does it as early as possible. So that one's great. So, but those two parts are very important bits. You'll see that. Sorry, build up. Like I said, I just wrote this talk beforehand, so I'm improvising. So the actual mop. So the mop is a meta object protocol. Mop is essentially an interface to things like classes and methods and slots, and also in this case roles. So roles are a concept that, well, they go back to Smalltalk in the trades paper a long time ago. Perl 6 picked them up. We introduced them to Perl 5 with Moose and some other things, and they've gotten pretty good traction. Most other languages are starting to have something like this. Traits in Scala. Rust has traits, stuff like that. So mop role is basically an API to all that kind of stuff. It is based on universal object in the sense that it follows the has convention for the slots. Okay. It is also stateless. This was one of the big problems with Moose, was that Moose kept all this state in the meta object, and all this state basically was in the Perl interpreter, and it had to keep them in sync at all times. And that cost a lot. This doesn't care at all. All state is stored in the package in some way. So methods are stored in the stash, slots are stored in has, inheritance relationships are stored in ISA, et cetera, et cetera, et cetera. We don't store any state, so this makes them very easy. They're minimal overhead. They have very little extra memory added because they essentially just bless a reference to whatever it is they're introspecting. So bless a reference to the code, bless a reference to the actual stash of the class. And so this allows them to be built lazily, and then have minimal overhead. So again, fixing some of the stuff in fixing some of the stuff in this is essentially how they work, how they fit together. A role is going to have a bunch of methods, one for each method in the class, and have slots, one for each corresponding slot. Mop role covers all this functionality because a role pretty much is something that has methods. And basically, the only difference between a role and a class is that a role can't be instantiated and a class can. So a mop or a class can pretty much have all the same capabilities of a role. So mop or a class does a role. Class does role. Does that make sense? Right? Okay, that was clear, right? Anyway, so it's meta circular in that way, but it's low overhead. So So, sorry, this was what I was talking about before. Inheritance information is in the ISA. The methods are stored in the actual package stash. The role relationships in does, and the slot information in has. It produces a very small overhead. So you end up. Okay. Sorry. Yeah. So if you remember this before, we had. Sorry, like I said, just was writing the slides. I was sitting up there. We have the has, so we have the x and the y for the point, and then we want to inherit here in point 3. Well, this is a pain to have to do this. And one of the things about Perl OO that has always been painful is that you repeat the same strings all the time. So there's always a possibility of a problem. So here comes the mop. So mop role new. Okay. Now you all remember before that looked like a class, right? So why am I doing a role here? Well, because a role is a subset of a class, and I don't care about the function. For what I'm going to do, I don't care really about the functionality. Actually, no, should I do? Never mind. Ignore me. Forget about that. Anyway, I create a bunch of roles in there. Go in the MRO. That's the postfix dereference syntax. Very nice. You should all try and use it. So what this does, though, is this goes through all the different classes that I inherit from. Okay, so that's going through all the MROs there, that first loop. In the second loop, I get all the slots in all those classes, and then I go through, and if I have the slot of that name, or if I have an alias slot of that name, I skip this. But otherwise, I put it in there. And what this essentially does is it grabs all the inherited slots, pulls them up, and merges them cleanly into one spot. So this is the type of thing that the mop can do. It can manipulate and combine all these things together for inheritance. The role composition works in the same way. So it's the API into the methods, the slots, the roles, and the classes. And you can build stuff back. So, and I'm running way low on time. So, real quick here. Method traits. How many of you know Perl 6 traits? Or Python decorators? Java annotations? Okay. So it's like that, but it's better described as an actual use case for code attributes. We all know what code attributes are. For those things after a colon on a subroutine that nobody ever uses, and everybody's like, what the hell? You probably use them, yeah. A few of us have used them in anger here and there. I've never found a good use for them because there's such an annoyingly tricky and difficult API to get your head around. So every time you get 5 minutes into it, you go, forget it, it's not worth it. So I finally persevered. So because I really do like annotations in Java, I want a similar feature in Perl, and I want it to behave in very much the way that Perl 6 traits do. So that's what we have. So you have to load a trait provider, which is essentially a package with subroutines named for your traits. Okay, you're basically just associating a handler with other stuff. So what this will do in the background is it will actually use that B compiler phase hooks to install a begin block that will install all the things that you need to collect all the weirdness of the Perl API to collect this information and to apply, and to apply the provider, and then it'll remove itself. It'll then inject another begin block to remove all evidence of that. So you don't see that you just used a feature in Perl. It takes it all away. It cleans it all out because essentially, otherwise you mess up your namespace. So that's how to implement that. That's all you do. That's your provider thing. The handler gets the meta object. So this is a mop class object. The method name that you attach this to, and then any other additional information. So if you remember beforehand, we have the type, read only, read write, and then the slot value. So basically just write this, and it uses the mop again to add a method of the name, and it creates a read-only accessor or a read-write accessor, and using the slot. This is also introspectable, so if you get a mop method object, you'll find that the code attributes are there, so we do leave those in there because Perl expects them. Then you can also grab the actual trait object, which will have it broken down into the actual name of the trait, the arguments for the trait, and then you can actually find out the fully qualified name of the handler that's going to be calling this one. You can get crazy with this if you want. Get opt here. So we're getting this string. We're going to obviously turn this into an op spec, right? And then we got these. This is also, by the way, not only is it maybe a good use case for this feature, it's also maybe a good use case for the pre-declared subroutines. Because I'm going to build the entire guts of this. I might as well just not bother setting it up. Get-off is implemented like this. Okay? Now you're all going, what? That's because get-off, and again, if you've worked with Java annotations just smack some stuff onto your class, and then you can tell Java annotations whether you want them to keep it at runtime or do it or just keep it for compile time. But another class has to inspect that and do something. So it separates the concerns a little bit there. So in this case, just for this case, I implement get-off in this way. So I can loop through all the methods in my meta, so assume that's my class. I can get if I have a code attribute that is opt, so I know that I'm looking for that, I can get rid of them if I don't have it. Get the trait, make sure that the trait is also opt, and then from there I can build the op spec. So I had all those strings, I can start to slice them up and build the op spec, and then I can pass it into get up long, and then I can put my values out, and I can be done. I actually have a test of this that works with all the code that's missing that I'm commented out here. But there's this. This is also, if you're familiar with Jackson, which is a Java library for JSON serialization and data binding, this same thing could be implemented through the same way. Also have a test that shows that working. If you use the JAX-RS web service annotation sets, those are also very nice. Hibernate has some annotation sets for validation. Basically, porting all these things to Perl would give us a lot of stuff. And as I said before, all this happens at begin time. So it all happens early in your process outside of your pre-call. So, okay. 10 minutes, so this is fast. Moxie is the Moose redo, but not really. So I don't have a better name for it. If anybody has a good name for it, we can come up with one. But essentially, it uses all those things that I just showed you before. So extends and has are both implemented with begin lift. So again, these things all happen very early in the compile time and turn into the canonical versions of themselves. We're using method traits. So we have all your standard Moose things. You have your read-only accessors, your read-write accessors. We have predicates that you can set up clearers, like a lot of those features in Moose to generate different types of accessors. It did it here, or we have versions of it here, and you can see also what we extend. Now, one of the things I know some of you might be looking at these and saying, okay, we've got some redundancy here, right? We got X up there and Y. Why aren't we associating our accessors with that? Well, again, compile time, it'll know it's here. There's less for me to generate. I just have to stick in a new version or a new sub, but the glob is already there, so we're doing less work. Number one, and two, sometimes you want encapsulation. So one of the biggest criticisms I've always gotten with Moose is it encouraged struct-style classes, meaning you create a bunch of fields for your class, and then you have accessors for all of them. And everybody can get to everything, and everything's public. So with Moxie, that's not the case. You can set your accessors and your slots are separated differently. And then and there's also private accessors. And when I say private accessors, and I totally forgot to put a slide in here for this. When I say private accessors, I mean we generate lexical subroutines that are not available in the dispatch of the actual class, and they are also not available to anybody outside of the class, because they're truly lexical subroutines within the scope of the package, and they know what self is automatically. So you can basically do all self. I totally forgot to get a slide for that. It's in the test suite. Anyway, point is we're generating a lot of these accessors for you in a slightly different way than normal Moose, but it allows you a better set of encapsulations. You can have a better separation between what is your state, which is the slots that you have, and then what is your access, and how do people access that state. It also works with overloading and stuff like that, so we got the accessors there. This is just because signatures, because apparently overloading sends a whole bunch of extra arguments into your thing, I don't know why. Also Moxie also turns on signatures, and Moxie turns on postfix deref, it turns on current sub, it turns on lexical sub, it turns on postfix deref QQ, it turns on ref aliasing, it turns on every cool new feature that you could ever want, including strict and warnings, in its import. So it's sort of like Moose in that sense, and then it forces you forcefully into the future. So this is a test that sort of runs, but doesn't actually entirely work yet in there, and I'm just using my last little bits here. But I just want to show how you could extend things with the traits. The method traits mechanism, Moxie supports it already, so we can guess what this does. It's a read-only accessor for the description. JSON parameter just tells it, hey, when you're collapsing this object from JSON, make sure you store a field for description and a field for is done. And when you pull it back out, you can do the same thing and get it out of there. So these are just annotations. Again, they run outside. Yeah, I know. You're looking at me like, what? Yeah, I'm sorry. I'm going really fast here. Anyway, wouldn't this kind of stuff be cool? I mean, Catalyst did all sorts of messy shit with this stuff. But now we have subroutine signatures. We can add these annotations here. Here we go. Ta-da! Web service done. Okay. And what's happening is there's not much going on in the class. So the class is very, very testable because what's going on with puts and consumes, it doesn't do anything to the class. So the class on its own is entirely testable by itself in this way. Now, I may have a runner that understands all this meta information in all these places, and then creates something that runs this and properly delegates to these other bits that are just in the database. Again, if you look at JaxRS and some of the Java annotation stuff, it works out very nicely because you add all this meta information, you don't really need to care about it when you want to test in isolation. But then when you want to run it in a particular environment, the meta information adds. Anyway, sorry. Okay. What? So, yeah. We're building on this. It's getting there. The status. Universal object is stable. I've been fiddling with this thing for, I don't know, like 8, 9 months now. I've been writing a bunch of new classes in it and stuff like that. That's entirely stable. I totally recommend people trying to use that, playing with it. I'd love bug fixes, feature suggestions, other stuff like that. Doc fixes. The other two, they involve XS that I wrote, so I'm not going to put them above alpha until I get somebody else to look over my C code. But those ones, they work. Not that they don't work. Just I wrote the C, so that's a bad thing. The mop, I'm calling it beta, but this has been around for at least a year and a half now, and I've been using it in various places for at least a year and a half now. I'm calling it beta because also there's a bunch of stuff that should be moved into XS that is currently using the pure Perl, horrible, crazy, weird approach to it. You move it into XS, it'll be a lot faster, but again, I shouldn't write that XS, and that's complicated XS. But that's fairly stable from an API perspective. Method traits in Moxie, I was hoping to get released like before the talk, but I didn't, because I was working on the slides. So, but these things are moving forward. I spent 5 years fiddling with this project and this idea of getting some more modern stuff into Perl, but to get it into the core. And finally, now we're moving forward in this. So, yeah. Questions, thoughts? I don't know if I have time enough for questions. Actually. 3 minutes. 3 minutes. 3 questions. 1 minute. 2 minutes. So the plan and the rule was always put it on CPAN, give it a little bit of time to shake out all the bugs and stuff like that. Then we'll move it into core. It's a negotiation. I'm basically Sawyer and everybody in T5P running through stuff like that. At the moment, they're all very minimal on their dependencies. It should be pretty easy to install from CPAN. Worst case is you have to get a new testable or something like that, and that pulls down the whole load. But yeah. Questions?
Your begin lit, how does that compare with Zephyrum's Devel begin lit?
So I couldn't figure out his thing. The only thing that I was able to sort of figure out at one point was there's a Devel begin lift, which Raffle wrote, but that's full of crazy stuff
I
as
thought
well.
that was Zephyrum's. Okay.
No, this is Zephyrum's. So a couple of people have tried this in various different ways. I didn't care about some of the things that they cared about, and they didn't care about some of the things I cared about.
Okay.
Eventually, I'd like to see them all merge because I think they all try and do the same thing.
Yeah.
But they're just level
just
crazy.
different things. Okay.
Yeah. Any other questions?